Alright, so I created my first video, but I forgot to add the last example in. So today I'm gonna go over this example, last example on the PowerPoint. Also, I hope everybody's safe, remaining healthy, staying away from the corona. Hope you got your PJs on for pajama day. So we've been talking about rational functions. With rational functions, a few rules that you gotta know. When we're finding our vertical asymptote, all we're doing is finding our domain. So we set our denominator equal to 0, solve for the variable. We'll say that variable cannot equal whatever number that you get. That is also how you find your vertical asymptote. Another asymptote is the horizontal asymptote, and I emailed you 3 different rules. So if it's all about the degree, if our degree is lower in our numerator than the degree of the denominator, then your horizontal asymptote is at 0, y equals 0. If your degree is the same in your numerator and the same as the degree in your denominator, then your horizontal asymptote is the fraction of your coefficients. Lastly, if your degree is higher in your numerator than the degree of your denominator, then you have no horizontal asymptote. All right, so as long as you can remember those rules, you'll be just fine. So today I'm gonna go ahead and explain this example. So it gives us in the last slide, f of x equals 1 over x plus 2. So the first thing I'm going to find is my domain. I'm finding my domain first because that's the same process that I need to do to be able to figure out my vertical asymptote. So I'm going to take my domain, which is x plus 2, and set it equal to 0. To get x by itself, I subtract 2 from both sides, which tells me x equals -2. Since x is equal to -2, my domain would say that x cannot equal -2, which means that my vertical asymptote is at -2. In this example, our degree of our numerator is less than the degree of our denominator. So my horizontal asymptote is at 0. I can say 0 or I can say y equals 0. Same thing. Once you figure out your vertical asymptote and your horizontal asymptote, you can go ahead and start creating your graph. So I create my graph, and if I need different colors, I got different markers, so hopefully that'll work out. Turn my living room into my classroom. Girlfriend not too happy about that, whatever. All right, so let's go ahead and graph this out. My vertical asymptote is here at -2. So my vertical asymptote is at -2. We create our vertical asymptote with dashed lines. My horizontal asymptote runs through my x-axis. So I would create a dashed line through this, but it's already a solid black line. Last thing we gotta do, we gotta pick points to the left and to the right of our asymptote, right? So this is -1, 0, 1. I want 3 points to the right of my vertical asymptote, and I want 3 points to the left of my vertical asymptote. So like I said in the previous example, we're going to create a table so we can remember our points. So we got x, y, and I'm using -1, 0, and 1. I'm also going to use -3. I would use -4 and -5, but I'll explain once I get to this point on how we graph this out. So in order for me to figure out my point, to find my y value, I'll plug in -1 into this expression. So 1 over -1 plus 2. negative 1 plus 2 is equal to 1. So this really equals 1 over 1. 1 over 1 is equal to 1. So at negative 1, I got a point at negative 1, 1. Next point is 0. So if I plug in 0, I get 1 over 0 plus 2, which gets me 1/2. So my next point is at 0, 1/2. Last point I'm going to plug in is positive 1. So if I plug in positive 1, I get 1 over 1 plus 2, which gives me 1/3. So I got 1/3 for this point. So at positive 1, 1/3, I'm getting close to my asymptote, but not quite touching it. So on this side of my asymptote, remember our lines does not cross or touch our asymptote. So when I create this line, it gets close, but doesn't cross. So the graph to the right side of our asymptote looks similar to that. Not the perfect line, I know. On the left side of my vertical asymptote, I would choose these 3 points. So I'm going to plug in negative 3. So I got 1 over negative 3 plus 2, which is equal to negative 1. So at negative 3, negative 1, I'm going to erase this so I can show the point a little bit better. So at negative 3, negative 1, I have a point right here. And as you can see, for us to get our curve, I will have to use a fraction to be able to figure out where our point is at this way. And obviously this line's going to keep going closer to our asymptote, but it won't cross, right? So in this one, I'm not going to plug in all of the points to be able to create this graph because I know that this graph looks like this. All right.